Hi everyone, this is my paper, one of the papers which I've chosen, and it's titled Semi-Supervised Multitask Learning for Sequence Labeling. And the task addressed in this paper, like the title suggests, is sequence labeling, but I have focused on the NER aspect of it. But the original paper also does error detection, NER, chunking, and pause tagging. The input to this this approach is a corpus of sentences that tokenized in this format, which is the word, the pause tag, the chunk, and the entity type. Glove embeddings are used, and the output is any NER task is tags predicted for each token in the sentence. So, like this diagram indicates, the forward LSTM predicts what the next word in the sequence could be, and the backward LSTM again predicts what the previous word in the sentence could be. And like the uh, title suggests, it uses a secondary objective of language modeling to enhance the performance of the primary objective, which is sequence labeling. So, predictions of the next word and the previous word are then used internally in the model to kind of predict what the label for the current token could be. So, this BiLSTM is used in conjunction with CRF layer or CRF layer to generate predictions or predict the tokens for predict labels for each token. And moving on, I'll just briefly show the results which I've got. The evaluation data sets were the CONLL 2003 on to notes 5.2, which is, and then the ChemNER, which is the biomedical data set, and the evaluation metrics for precision recall in F1. These are the results which I have obtained, and you can see that adding the language modeling objective improves the performance of the model by a considerable amount. And this graph indicates how the same has been achieved. So with the baseline, it kind of tapers off after the first few epochs, but then it gets significantly better with the language modeling objective. These are the numbers which I've obtained after running it for 10 epochs on the first two data sets and running it for 2 epochs on the third one, because each epoch took considerably long time. And coming to the implementation, I'll just quickly run through my Jupyter notebook. So first what we do is we kind of give the paths to our train, test, and dev data sets and post that you instantiate an object of the sequence labeler class. And the dataset used here is a sample dataset which contains limited sentences for each of the train, test, and dev. Once the dataset has been read, it returns data in this 12 tuple format, which has been decided by our NER group. And post the vocabulary is built, and then what we do is to preload the vectors, which are the if it's already existing, otherwise we build them, preload embeddings, and then the model is trained, and each epoch could take a while. And since this is a representational data set for the purpose of the demo, you can see the numbers which are obtained after the training. And the early stopping condition is used when it starts to converge. We kind of stop the training, and then the labeler.predict function kind of predicts what the NER tag for each token could be on the test data set, and the predictions are returned in this format. The first two are not used in this implementation, so it is none for everything. And the last two indicate the tag, I mean the word and the corresponding tag which has been predicted by our model. And once the predictions are generated, our task would be to kind of write those predictions into a final output file and then call the evaluate method for evaluating the performance. So the metrics which we have decided as our group was precision, recall, and F1, and we report these three numbers. So that's about my first paper.